which is a pre-cal level.
Yeah.
Okay, so all the thing like no need to hesitate by if you have any doubt for this. Okay, so and if you know something, you quickly uh, move forward and you can mm, without hesitations again you can share it that you know it this one. Okay, so we can start or like we can finish it quickly as well if you know something. If you don't know and not remembering it, I'm going to do each and every part of this. So the angles in the trigonometry, so angles derive from the Greek, like as the word trigonometry means measuring the triangle. So originally trigonometry deals with the relationship sides of the angle and of the triangle, instrumental of the development astronomy. So these are the some parts they have given it. So here the classic trigonometry relationship as a function within a set of the real number as their domain, and consequently the application of trigonometry expanding the physical phenomena. So here the first thing that we are going to know is about the vertex, like for the angle. And so for the angle, these are the terminal side, these are the initial side. Okay, so angle in the standard form or standard position. So as we know, we have to measure the angle anti-clockwise. So initial side, terminal sides angle will be this one, angle in a standard form. Got it?
Yeah.
Next is rotating. This is very basic, it's very important. Okay, so if you have doubt for this one, just let me know immediately. Okay, without any hesitations you can tell, and if you really understand it, then you can share it. Okay, if you still have some doubt, simply one thing or something, you can feel to share. Okay, rotating a ray which is a half line about its end point determine an angle. The starting positions of the ray is an initial side of the angle, as we know in the previous as well. The position after rotating a terminal side, right? Initial side and terminal side, initial side and terminal sides. So the positions after rotation is terminal side, as we can see in the previous figure. Got it?
Yeah.
In second one, the end point of the ray of the vertex is the angle, and the perceptions of the angle fits the coordinate system in which the origin is in vertex and the initial side coincides with the position of x-axis. Such an angle is a standard position, as we did in the second one. So initial sides and terminal sides, angle in a standard position. Got it? Now in the second, as we did, as I already told, is anti-clockwise and counterclockwise rotations generate a positive angle, and clockwise rotation generate negative angles. Okay, anti-clockwise positive angle, clockwise negative angle, that you are going to remember it. And as in figure, we have to label the angle can be in Greek letter alpha, right? This angle is the counterclockwise, which is positive angle alpha, and the beta, which is clockwise, is negative angle, right? And theta, which is upper letter, which is ABC. So theta, which is a small angle. So and alpha, beta, and theta. Theta is an angle. Now here you can see that it is the one revolution, right? More than one revolution. So alpha and beta have the initial and terminal side, and such angles are coterminal. Coterminals are, so this is the angle, and coterminal of this angle will be this. that is the beta. So the angle alpha and the beta same initial and terminal side, and such angle initial and the terminal side, and such angle is the coterminal angle. Got it? What is mean by coterminal angle? And how the positive angle, how the negative counterclockwise for the positive angle, negative angle for the clockwise, coterminal angle. These are the term that you need to understand it. So did you got it from this point, Rihan?
Yeah, I got it.
Good. Let's move to the next. Radian measures. Radian measures the amount of rotations from the initial side of the terminal sides determine the measures of an angle. We can see that the amount of rotation from the initial side to the terminal side that determine the measures of an angle. One way to measure the angle is radians, and this type of measures is especially useful in calculus. To define the radian, use a central angle of the circle, and which is an angle whose vertex is the center of the circle, as we can see in the figure as well. This is the central angle. Now, measures of an angle. One way measures the angle of radians, and the type of measurement, especially for in calculus. Central angle, right from the center, get central angle, which angle whose vertex is the center, right? We can see that vertex is the center, right, of the circle.
Yeah.
So that's why the central angle. Arc length, which is the radius when theta, right? Arc length, which is the radius of theta. 1 radian, which is the 1 radian. Now, the next is definition of the radian. That is highly important.
Okay. Yeah.
1 radian of n measures of the central angle theta and intercepts of an s equals in the length of n radius r of the circle. Algebraically, this means that theta equal to s over r. Theta is the measures of radians, and theta equal to 1 and the s equal to r. Okay, that is for the definition of the radian. So s, which is in a theta measure in radian, so which is nothing but to measure the central angle of theta intercepted the r s equal in the length of the radius r. So next is circumference of the circle. Circumference of the circle is 2 pi r units. So it's the central angle of the full one revolutions, or which is the anti-clockwise or counterclockwise, corresponding to an arc length s equal to 2 pi r and 2 pi, which is 6.28. So that does over 6 radians length is in full circle. And you can see that 1, 2, 3, 4, 5, 6 radian in a full circle. Okay, so the units of the measures of the s and r is the same. So the s over r has a no units, so it is a real number. So measures of an angle of the one full revolution s over r, which is 2 pi r over r, which is 2 pi radian. So you can obtain the following: half revolution is 2 pi over 2, which is pi radians. 1 over 4 revolution is 2 pi over 4 and pi over 2 radians, and 1 over 6 revolution, which is 2 pi over 6 and which is pi over 3 radians. Okay, so they have full revolution is 2 pi, half revolution is 2 pi over 2, which is pi radians. 1/4 revolution is 2 pi over 4, or this pi over 2 radians. 1/6 of revolution is 2 pi over 6, which is pi over 3 radians. Got it?
Yeah, got it.
Now, these and other common angles which is shown in this below. Now we have to recall all 4 quadrant now, right? So this is the first quadrant, second quadrant, third quadrant, and this fourth quadrant. So 4 quadrant of the coordinate system, which is letter 1, 2, 3, and 4. This figure below, as we can see that in between 0 and 2 pi lie in each of the 4 quadrant. So first quadrant, second quadrant, third quadrant, and fourth quadrant. Now the angle between 0 and pi over 2 as an acute angle, and the angle between pi over 2 to pi, which is an obtuse angle. Acute angle is less than 60. Obtuse angle, which is greater than, you can see that, 90. Obtuse angle, less than 90 and greater than acute angle, obtuse angle. Got it? So as
Yeah,
an
got it.
acute angle, which is pi over 2, so pi over 2 is 1/4 of revolution, right? And pi is 1/2 revolution. 1/2 revolution is 180. Got it? In between this, which is obtuse angle, 0 to pi over 2. Pi over 2 is pi over 2, which is 1/4 revolution. So pi over 2 revolutions. Got it now? 0 to pi over 2, pi over 2 to 0, pi, and pi to 3 pi over 2, and 3 pi over 2 to 2 pi.
Yeah.
Now the two angles are the coterminal when they have the same initial and terminal side. The property is, two angles are coterminals when they have the same initial and terminal side. For example, angle theta and 2 pi are the coterminal as the angle pi over 6 and 13 pi over 6. And to find an angle of the coterminal to given the theta, we add or subtract 2 pi in one revolution as in demonstrated in the example 1 we are going to do. And so it's given that the theta has an infinitely many coterminal angle. For example, theta equal to pi over 6 is a coterminal within pi over 6 plus 2 pi, 2n pi, where n is an integers. Now, next example, which is of finding the coterminal angles. Finding the coterminal angles. So, finding the coterminal angles. For the positive angles, 13 pi over 6 subtracted 2 pi to obtain the coterminal angles. That's the questions we have. So 13 pi over 6 minus 2 pi as we did. So it's pi over 6. for the B part, you have to, for the negative angles, negative 2 pi over 3, add 2 pi to this in the coterminal angles. So we have negative 2 pi over 3 and plus 2 pi, and which is 4 pi over 3. Okay.
Okay.
Now we can see that this one is anti-clockwise, right? Positive angle pi over 6. This is, which is the angle, right? Now theta, which is 13 pi over 6. Okay, and this will be pi over 2. This whole will be pi, and this to this is 3 pi over 2, and this is whole 2 pi. Okay. Now for the B part, as so we have negative 2 pi over 3, right? Negative 2 pi over 3 we have, and we adding 2 pi to it, so which is we got 4 pi over 3. 4 pi over 3 is this. Understood? So finding the coterminals. For the first one, we have to subtract it, as the angle have 13 pi over 6 we have. We subtracted it and we got pi over 6. To obtain the positive angles 13 pi over 6, we have subtracted 2 pi to obtain the coterminal angle. And for here, we have the negative angles, negative 2 pi over 3. So here in this case, we can add it 2 pi and we can get the coterminal angle, which is 4 pi over 3. Understood how we are getting this one?
Just added the.
Yes. When we
Is it like
add it,
two
when we
cycles?
subtract.
Is it just like a cycle? Because it's.
Finding the coterminal, if negative, we can add 2 pi, and if it's positive, we can subtract 2 pi. Okay. Let's do the examples. Here we have complementary angles and then supplementary angles. But did you got it, like finding the coterminal angles? If you still have any doubt, just let me know. Did you got it? How we are getting the,
Yeah, I have some doubt. Can you explain it one more time?
or one thing you can do, you can go through this one and go through our 2 questions and then let me know. A complementary angles and supplementary angles. Complementary angles, as two positive angles alpha and beta are complement of each other when their sum will be pi over 2. Complement is pi over 2, which is 90, right? Pi over 2, pi over 2 radians, or in degree it is 90 degrees, isn't it? Pi over 2 radian.
Yeah.
And supplementary, which is straight angle, which is pi, right? Supplementary
Yeah.
angles of each other, which is pi, and pi is nothing but pi radians is 180 degrees, right? So two positive angle alpha and beta, they are the complementary. When complement each other, their sum will be pi or 2. Two positive angles are supplement of each other when their sum will be pi. Now let's do based on this. complementary and supplementary angles. I'm directly uploading. So complementary and supplementary angles. The complement of 2 pi over 5, 2 pi over 5, which is pi over 2, as complement is, angle will be complement, which is pi over 2, right? Whole will be adding this 2 angle, which is pi over 2. So we have to subtract it pi over 2, which is from pi over 2, 2 pi over 5, and we can get complement of 2 pi over 5, which is pi over 10. Got it? What did it is? We have to find the complement of 2 pi over 5. As we know, the complementary angle is, the whole angle is pi over 2. So we have to find complement of this. So that's why we subtracted from pi over 2, which is 2 pi over 5. And if you're simplifying it, so it'd be pi over 10 minus of just multiplying. This will be by 5, and so it's 5 pi over 10 minus this is into 2 into 2, so it's be 4 pi over 10, and we got 10, 5 pi minus 4 pi, so which is we got pi over 10. Understood?
Yeah.
Now the supplementary of this we have to find, and supplementary is, as we know, supplementary is pi. Sum will be pi. So supplementary of 2 pi over 5. So whole will be pi. So it's pi minus 2 pi over 5. For here, and just multiplying this by 5 over 5. So I got 5 pi over 5 minus 2 pi over 5, and then 5 pi minus 2 pi over 5, which is 3 pi over 5. Understood?
Yeah.
Now there is a no complement for the 4 pi or 5, because 4 pi or 5 is greater than pi over 2. Remember that complements have positive angles, and supplement of 4 pi or 5, which is pi minus 4 pi or 5. Simplifying it, we got pi over 5.
Yeah. Understood.
Now the next is degree measures. That is again very important. So another way to measure the angle, which is degree, as I told you, denoted by the symbol degree. A measures of an the degree is 1 degree is equivalent to the 1 rotation of 1 over 360 complete revolutions about the vertex. To measure the angles, it is convenient to mark the degree on the circumference of the circle as this figure. Full revolution is counterclockwise, which corresponds to 360 degrees. Half revolution is 180 degrees. Quarter revolution is 90 degrees, and so on. One complete revolution is correspond to 2 pi radians, and so degree answer, which is 360, which is equal to 2 pi radians. Pi radians is 180 degrees, and half of this is 1 degree is pi over 180 radians, and 1 radian is 180 over pi. Which of the conversion we can do this? So for the conversion one, there are the formulas. Conversion between degrees and radians. Conversion between degrees and radians. To convert the degrees to radian, multiply the degree pi radians over 180. Okay, when we converting degrees to radians, we have to multiply this by pi radians over 180, and by converting radians to degree, we have to multiply 180 degrees over pi radians. To apply these conversion rules, basic relationships, pi radians is 180. So pi over 6, pi radians is 180. 180 over 6 is 30 degrees. 180 over 4 is 45 degrees. 180 over 3 is 60 degrees. 180 over 2, 90 degrees. Pi is 180 and 2 pi is 2 times 180 is 360 degrees. Understood? Very simple. What you have to remember is pi radians is 180. Okay, and here the conversion from degree to radian in between. When there is a no limit of angle measures specified, radian measures is implied. For example, theta is 2 imply that theta is 2 radians. Let's do the example. You can understand better. Converting from degree to radian. Converting from degree to radian. First one, 135 degree. Degree to radian. So as we know, from degree to radian, we have to multiply pi radian over 180. That is simple formula. So we have 135 degree and degree we have, and radian, pi radian or 180 degree. So this degree 180. So it's simplifying it, right? So which is we got 135 radian over 180, right? We are just simplifying it. 5
Yeah.
2s are 10, 5 7s are 35, 5 3s are 15, 5 6 are 36. Again further simplifying it. 9 3s are 9, 4s are. So we got this is pi. So 3 pi over 4 radians. For 540 degrees, so same thing. So which is we write 540 degrees, which is times with pi radian or 180 degree. So degree will get cancelled out, and so we have 540 over 180 pi radian. Simplifying it, 2s are 6 are 2 1s are 2 3s are. So which is we got 3 pi radians. Okay, it's very simple. Same formula we have to use it. Now you can use the calculator as well. Like some questions we have to use the calculator directly. You can just plug in it. So calculator is a convenient to use the decimal degrees and denote it. And here 1 minute, which is 1 over 60 times 1 degree. 1 second can represent this by, so 1 or 3600 into 1 degree. For example, we would like to write in theta of 64 degrees 32 minutes and 45 seconds, which is 64 degree 32 minute and 45 seconds. So many calculators, a special key for converting the angles, degrees, minutes, and seconds, degree, minutes, and seconds to decimals, degrees to for the vice versa. Now we have to converting from radians to degree. Converting from radians to degree. So radian to degree, negative pi over 2 radian, which is negative pi over 2 radian. We have to multiply this by 180 degree or pi radian. So radian get cancelled out. Pi get cancelled out. So it's be negative. So and 2 ones are and 2 90s are. So it's negative 90 degree. Got it? For this,
Yeah.
simply multiply. We have to simply multiply pi radian over 180 degrees. Two radian. 2 radian is, no, I did wrong here. 180 or pi radian. Radian. Now 2 radian we have. 2 radian we can write 2 radian. We have to multiply 180 degree or pi radian. Pi is nothing but the 180 degrees. And we have to simplifying it. So it is cancel out 2 times 180 degree or pi. So which is 360 degree or pi, or we can write 114.59 degrees.
Okay. Yeah, makes sense.
Yes. Now let's try a few examples. You can try it. This will become later. So maybe after finishing some questions, you can try this one. So let's try what we did already. Try question number 7. Now 8 for the homework. Can you try?
7. That's like 45 degrees, right?
Read the clearly.
45 degrees to the nearest half radian.
So for Seventh one. What is the question? Can you read aloud?
Question 7 through
Yeah.
10. Estimate the angle to the nearest to 1/2 radian.
Yes.
Oh, so it's I think it's pi over 4 radians, right?
One, to convert, I can explain. Convert angle is 1/3 of half rotation. So to convert degree to radian, which is we have to multiply degree by pi radian, which is 180 degrees. So 1/3 of pi, which is 1 radian. Got it? This much. Now this one for the 8 for the homework. Let's try 9.
Estimate the nearest angle, nearest 1/2 radian. So this is like half of it, right?
So here the angle which is clockwise, the given approximately 9 or 10 of half rotation. Hence 9 or 10 into negative pi, and which is negative 9 pi over 10, and which is negative approximately 3 radian. Okay. Can you try question 11? Now,
Question number 11.
yes.
It's the first one, right?
Read it. Read the question and write it down the answer.
Determine the quadrant in which each angle lies.
If you not remember, you can move back and quadrant part and
Yeah, I'm
refer.
doing it in my notebook. You have to first convert it to an angle first, correct?
Yes, it's the quadrant. Refer this one and go back to the other question and retry. Are you trying it? Aryan?
Yeah.
Okay. part?
It's in the third quadrant. Right? Wait, never mind. It's in the second quadrant because it's behind.
It's negative 5 pi over 4. I'm moving back and tried it. Negative. So for this one, I'm going to explain you. It might be confused sometimes. So for this one, we have an angle between. We have to note that the angle which is negative 5 pi over 4, the angle between zero and pi over 2. So which is in quadrant 1. We have to note that the angle pi over 2 and pi which is in quadrant 2nd. We have to note that the angle pi and 3 pi over 2 in quadrant 3, third. And the angle between 3 pi over 2 and 2 pi which is a quadrant 4. So since here for negative 5 pi over 4 which is less than 0, and we have to add 2 pi until angle between 0 and 2 pi. So negative 5 pi over 4 plus 2 pi which is 3 pi over 4. So 3 pi over 4 is between pi over 2 and pi, and which is the angle in the quadrant